Okay, let's look at limits. So some key ideas of limits. Limits describe how a function behaves near a point instead of at a particular point. So keep in mind, we're getting closer and closer to a point. We're getting near a point, but we're not actually at that point. So a limit that approaches, right, approaches a point on a function from the left side is called a left-handed limit. So if we look at this function, f of x, see f of x here is our graph. For the function f of x, the limiting value as x approaches 1 from the left side, so here we say here, as x approaches 1 from the left side. So from my left side, it's an x value of 1. So here's my arrow here showing in this direction. So I'm following along the graph until I get close to the x value of 1. As I'm approaching the x value of 1, what is my y value approaching? I'm approaching at 1, x value of 1, I'm approaching a value of 2. So here's how you read it. The limit as x approaches 1, the negative means from the left side of the function f of x equals 2. I'm approaching, getting close to 2. It doesn't mean it equals 2 because you have the word here limit. It just means that I'm approaching 2. Here's the exact same graph, just reproduced here. A limit that approaches a function on the right-hand side is called a right-handed limit. So for example, this same function f of x, for the function f of x, the limiting value as x approaches 1, the same value of 1, but now I'm approaching from the right side, right? As x approaches 1 from the right, so I'm coming in this way, my arrow is this way, coming in from the right, so I have to follow and be on the graph on the right-hand side. As I approach the value of 1, I'm getting close now. What is my y value? My y value is approaching, getting near 2. So my y value is my limit as x approaches 1 from the right side of the function f of x is a value of 2. So for the left-hand side, I had a value of 2. For the right-hand side, I have a value of 2, which is what this is saying. When both the left-handed limit and the right-handed limit exist, and they both approach the same value, then we say that the limit exists. So for example here, if the limit as x approaches 1 from the left-hand side was 2, and the limit as x approaches 1 from the right-hand side is 2, then the limit exists. And therefore, we simply say, therefore, the limit as x approaches 1, we don't have any left hand or right hand sign indication here, which means from both sides, the limit as x approaches 1, the function f of x from both sides is equal to 2, and then we say that the limit exists. So just to write that in. The limit exists if when I approach from the left and from the right side, I get the same value. And this here, there's no negative or positive sign because it means I'm approaching from both ways and I have the same value on both sides. Now that is different. This is saying limit. This says what is the value of f at 1. So this is function notation. Function notation, we're saying at the point of 1. Looking at the f of x function, what is the value at, now I am exactly on the point, at the point of 1, what is the exact value of y? So we'll go back up and look. At an x value of 1, go up on my graph. What is exactly the y value is 2, and that's why we wrote that down here. That f of 1 is equal to 2. A limit can exist for a function that has an open hole. So here's an example if we have, let's say what would be looked at as a choppy graph. Now again, this left-hand side graph and right-hand side graph are exactly the same. I'm just looking at it so I can put my arrows to indicate which way I'm approaching. So here it's telling me Here's my function f of x. So my function f of x is this part of the line, and it comes up and continues on here. Right, this part of the line, then it comes up here and continues on. That's my entire function. So if I'm looking at the limit as x approaches 3 from the left-hand side. So here, if I'm approaching from the left-hand side, I'm only getting an x value of -1. So then I have to come up here and continue. So my arrows are indicating I'm coming from the left. And I'm approaching 3. As I'm approaching 3, what is my y value? Again, what am I nearing? Notice how it's an open hole, but I'm not talking about exactly at the value of 3. I'm just saying, what am I getting close to? So I'm getting close to a y value of 2. Now, if I do the same thing from the right-hand side, if I'm looking at the limit of f of x of this function, as x approaches 3 from the right-hand side, so I'm staying on top of my graph, on top of my function, right? The arrows are going this way, indicating I'm coming from the right. I'm moving right to left. As I'm approaching the value of 3, what y value am I getting close to? Am I nearing? I'm nearing a y value of 2. So even though I have an open hole, the limit still exists, because coming from the left side and coming from the right side, I have the same values here. So I would write that as, therefore, the limit as x approaches 3, again, from both sides, no positive, negative sign. As I approach this function at an x value of 3, I'm nearing a y value of 2. So the limit exists. But notice, what is the value at exactly f at 3? Let's write this out first. So what we're saying here for the limit is as x approaches 3, right? As the limit as x approaches the value of 3, y is nearing or nears, that should say a value. Perfect. Y nears a value of 2. Whereas here we're saying f at exactly 3. F at 3, then it cannot be an open hole, right? Is undefined, because f at 3 does not exist. It's an open hole. So there's no y value when x equals 3, because we have an open hole there. What about a different scenario? What about if both the left-hand limit and the right-hand limit do exist, but they approach different numbers? They approach different y values. Then we say that the limit does not exist. So here's an example of where the limit would not exist. So here I have my function again, f of x is here, then the function continues on here to the right. It's the exact same graph on the left and right hand side here. So I know I'm approaching the value of -1. So if the limit as x approaches -1 from the left of this function f of x, so let's look, I'm approaching from the left. As I'm getting closer and closer to the x value of -1, what's my y value? I'm staying on -4 here, right? All the way along here. So -4. But my limit as I approach -1 from the right side, plus sign here, now I'm on the right side of the graph. I'm continuing on, right to left. I'm approaching the value of -1. Well, I'm getting close to a y value of 2 here, right? So both limits exist. The limit on the left-hand side exists and it's -4. The limit on the right-hand side exists and it's 2. But we say that the limit overall does not exist because there isn't one limit the same value for both. So therefore, we say that the limit as x approaches -1 for the function f of x does not exist. We say that it does not exist. Function does not exist. Now, this is a function, this graph, right? This function would pass the vertical line test because I have one solid graph, one solid dot here, sorry, and an open dot here. The vertical line test is only passing through one point because the point there does not exist. So this is a function. This would pass the vertical line test. If I had two solid circles, this was solid and this was solid, then it would not be a function and it would not pass the vertical line test, just to go over that with you, right? What about at f at -1? So if I go exactly, either graph is the same, right? F at -1, what is my y value? I have to go to where the solid dot is. So that would be equal to -4, right? Where the solid hole is. And if they both happen to be open holes, then f at exactly -1, I wouldn't have a value. It would not exist. Okay, let's look at an example that's not graphical. For each sequence, determine the limit or explain if the limit does not exist, why the limit does not exist. So here I have to figure out what my pattern is, right? So I have the numbers 1, 2, 3, 2, 3, 4, 2, 5, 2, 6, 2. So if I were to continue on dot, dot, dot there, what would the next couple numbers be? So I have 4, 2, 5, 2, 6, 2. So then it would be 7, 2, right? 8, 2, and so on. Am I converging? Are my numbers converging together and focusing in, narrowing in on one number? Is the limit approaching anything here? Then next would be 9, 2. Actually, my numbers are getting kind of farther and farther away from each other, right? So in this case, the limit, you can just say DNE, does not exist. Because again, my numbers are not approaching one particular number. They're not converging together. So if I were to take a look at B, -7.1, -7.01, -7.001, 0, 0, 0. You can see I'm adding an additional 0, 4 zeros, 1, 2, 3, 5 zeros every single time. Am I starting to slowly narrow in on one number? Is it focusing in? Am I getting closer to one value? So it was -7.1. Then I'm getting farther away from -7.1. And I'm getting closer and closer to the value, right? 0, 0, 0, 0, 0 is basically the number -7. And if I keep going, it's going to get closer and closer and closer to the value of 7. So it's getting closer to -7. So therefore, my limit is equal to -7. How about the next one here? If I see fractions, this is -2, or I could say -2/1. If we want to, I'll give you a second to take a look at what that pattern might be. How would I continue on with that pattern? So I have 1, 2, 3, 4, 5, 6 as the denominator, right? So the next one would have 7 as the denominator, then 8, then 9, so on. -2, -3, -4, -5, -6, -7, so -8, -9. Are these fractions closing and narrowing in, getting closer and closer to one particular number, one particular limit? So here I have a value. If you want, change these into decimals. So this is a value of -2, if that helps you see it. -1.5. If I were to take -4 divided by 3, I would have -1.3. You can just stop after one decimal. We're just getting the idea, right? Negative 5 over 4 is negative 1.25. Okay, I'm starting to see a pattern here. I'm getting away from negative 2, negative 1.5, negative 1.3, negative 1.25, negative 1.2 here. Negative 7 divided by 6 is negative 1.16. I'm actually getting closer and closer to the value of negative 1, right? If I continue on. So therefore, my limit is equal to negative 1. Okay, how about the next one? What is the pattern first? 125, comma, my next number is negative 25. So I must be multiplying by a negative number. What am I doing from one number to the next? My numbers are getting smaller, so I'm multiplying by a fraction, right? Or you could say I'm dividing by negative 5 each time. This number divided by negative 5, this number divided by negative 5, this number divided by negative 5. So I have positive, negative, positive, negative, positive. The next number would be negative. The next number would be positive. And I would have 1 over, take 125 and multiply by 5, because as a fraction, the number's getting smaller, right? So that would be negative 1 over 625. What number am I approaching? If I were to keep going, I'm getting closer and closer to the value of 0. So therefore, my limit is equal to 0. Doesn't mean that I'm going to equal 0, it just means that I'm approaching, right? The limit, I'm approaching a value of 0. What about the next one? Here I'm at 9.9, then 10.1. So here I'm starting below 10. Then my next value is above 10. Then I'm getting below 10 again, but closer to, above 10, but closer to, below 10, but closer to 10, above 10, but closer to 10. So I'm getting closer and closer to 10, right? Closer and closer to 10. So therefore, my limit is equal to 10. Okay, what if we looked at it in graphical form again? Examine the graph of h of x. So I've got this graph is going everywhere, right? It's curved, it's going up and down. It has closed holes and open holes. Here's a closed hole and an open hole. So I really have to be careful when I'm figuring out my limit, which direction I'm going in. So evaluate the following. The limit as x is approaching 4 from the left. So x is approaching, sorry, negative 4. See, I almost missed the negative. As x is approaching negative 4, excuse me, from the left, I just have part of the graph there to the left of negative 4. I'm going left to right, and I'm approaching the value of y equals 1, right? Oh, I almost made it through the video. So I have equal to 1. Try the next one while I grab some water. Okay, so let's say my limit as x is approaching negative 4. I'm approaching the same value, but from the right-hand side, right? So from the right-hand side, as I'm getting closer and closer, excuse me, to negative 4, I'm also getting close to a y value of 1. So therefore, the limit as x approaches negative 4 of the function h of x, the limit exists, right? Because it's the same value as I approach from the left and the right. So the limit exists and it's a value of 1. And the limit exists. Okay, I need to, so what is the value exactly at h at -4? At the value of -4, my y value is exactly 1. At exactly x equals -4. When x equals -4, what does a y equal? Okay, now we're going to be looking at the limit approaching 0. Zero from the left, 0 from the right, and h at exactly 0. So I'll go over the answers, then we can move up and write them in. So if I'm approaching 0 from the left, I'm over here. As x is getting close to 0, my y value is approaching 2. On the right-hand side, here's my function approaching 0. X is 0 here, right? So as I'm approaching 0, my y value is also approaching 2. So the limit exists. Here, this g, the limit as x approaches 0 from the left and right-hand side of the function h of x is equal to 2. H at exactly 0 does not exist. If I go to my x value of 0, there is no y value. It's an open hole, so it does not exist. So let's write that down. So I have here the limit as x approaches 0 from the left, remember, was 2. As x approaches 0 from the right is 2. And that means from both sides, the limit exists and the limit is 2. But h at exactly 0 does not exist because there's an open hole there. So now let's go back up and look at the graph as I approach +1. +1 from the left and right side, and then exactly at 1. So +1 from the left side, I'm going up on the graph, I'm up to here, I still have to go here. I am approaching a y value of -1. So equals -1 for I. From the right-hand side, I have to start to the right of the value of 1. So let's say here I am here, I'm approaching an x value of 1 on my function. I'm approaching a y value of 0, right? So my j is equal to 0. So therefore my limit values are different for I and for j. So then my limit as x approaches 1 does not exist. What about at h equaling exactly 1? At h equaling exactly 1, that's an open hole, that's an open hole. The only closed hole I have here, I have to say it's a value of 2. H at -1 is equal to 2 for y. So moving that here to fill out I, j, k, and l was, as I approach 1 from the left-hand side, I was approaching a y value of -1. As I approached 1 from the right-hand side, I was approaching a y value of 0. So because these values are not the same, then the limit as I approach 1 does not exist. And h at exactly 1, if you remember, the closed hole was at 2. Let's approach a value, an x value of 3 from the left side, right side, see if we have an overall limit, and see at exactly h at 3. So 3. So as I'm approaching 3 from the left-hand side, my y value is getting closer and closer. I'm approaching 0, right? So m would be equal to 0. As I'm approaching the limit of 3, but from the right-hand side, so I have to start to the right of the graph and go left, this is the part of my function h of x that I'm following along. And as I'm approaching the value of 3, my y value is actually 1. So it's equal to 1 for n. So m and n don't have the same limits don't have the same values. So then my limit as x approaches 3 for O does not exist. What about h at exactly 3? H at exactly 3, don't forget, we don't include the open hole. We have to include the closed hole. So the y value at exactly 3 would be 0. Okay, let's fill that in. And then we'll see how you guys do with the homework from the textbook. So the limit as x approaches 3, again, reading that from the left-hand side, using the function h of x is equal to 0. The limit as x approaches 3 from the right-hand side is equal to 1. These are not the same value. They don't, they're not both 0 or they're not both 1. So as x approaches 3, the limit does not exist. And h at exactly the value of 3, if I go to x at exactly 3, my closed hole was at 0, my y value is at 0.